So, assessing a regression model. So we know how to calculate a least squares regression line. And remember, we're going to be writing this a little bit today. So remember, it's doing it again. Alright, so we're going to be referring to this a lot. So if you want to, there we go, refer to this as LSR, I can spell, LSRL, that's the abbreviation for least squares regression line. Instead, because we're going to be writing this a few times today, so instead of writing over and over, you can just write LSRL. So, we know how to calculate it, we've seen it, we know how the calculator do it, but how good is the line? How efficient is it giving us information? Is it the right model, or would we use a curved line, like maybe, a parabola, or an exponential curved line? Would something else work? And if the line is the right model to use, how well does it fit? And how do we know if the line is the right model? So that's what we're going to be looking at today. So, if we look at this, these are graphs of similar data. So we have a situation where we're looking at superbowl number for our x and cost in thousands of dollars for our y. And this is the linear, the scatter plot. And there's the line that the calculator drew through the data. But if you look at the data just on its own, like if I could take that line out, do you see how this kind of looks like it's a little curvy? Okay? But you can draw a line through it. You can draw a line through anything. But there is kind of a slight curve to that. So what we're going to use is the idea of residuals. And remember, real quickly, if you have a line, residuals are these distances from here to there. Those are the residuals. You have some below the line, you have some above the line. What we're going to learn how to do today is actually graph those residuals. And that's what this is right here. If you notice, it says right here, that's the residuals. Notice x hasn't changed. And we'll get to some easier graphs, but if I counted all of these data that are below the line, it would match the number of data below the line here. If I took all the data above the line there and above the line there, that would match all the data above the line there. And it looks like I have one there, and I probably maybe have one right there hidden. It's going to match up perfectly. It's just going to be above and below the line. But look what we have here. If you look at this, we definitely have a curved pattern there. It looks pretty parabolic. All right? And that's what we're going to be looking at today using the calculator for. So, I'll hit pause. Here's a little bit of thing to write down. All right. So, definition. A residual plot, and that's what we just saw in the upper right, gives us a closer look at the pattern of the residuals. It plots the x values on the x-axis and the residuals on the y. So we get x here, and we get residuals here. So the x doesn't change. So whatever the scatter plot was, x stays the same. The y, instead of being the y data, is now going to be the residuals. All right, now the fun of the calculator. So, everybody take a calculator, and most of us are going to probably have to add something here. So everybody hit on and hit stat, and then hit edit. Now most of us are going to have L1, L2, L3, L4, L5, L6. You don't have what we need. So, first off, clear out L1, clear out L2, if you got information there. Okay, once we do this, you won't have to do it again on your calculator. So everybody go over to L3 and go up. Now, see above delete where it says INS? That's insert. So everybody hit second insert. Now, notice I have a flashing A. Hopefully you have a flashing A on yours. And we're going to spell out residual. Actually, it's going to be resid. Now, if you notice, there's letters here, A, B, C, D, okay? So we're looking for the R, which is Q, R, E, S, I, D. Just resid's fine. And then hit enter. Now, if you got a bunch of numbers in yours, the calculator is actually giving you the residuals from whatever the last piece of data was, even though we just deleted it. It already has that memory stored. So, up in residual, just hit clear and come back down. If you had data, it's going to give you the calculations even though we already erased it. It has the memory of what was in L1 and L2. Okay. Now let's look at what we got here. It says for the following data sets, we're going to put this information in and have all this fun. So everybody go ahead and put the data from your packet in. So over in L1, you're going to put 1 through 7. That's easy. 1, 2, 3. That's easy. Then you go over to L2, and you're going to put in 1, 5, 7, 8, 12, 12, 17. Okay? So you have your data in both columns, L1 and L2. Okay, we're going to do what we did yesterday. So everybody hit Stat, go over to Calc, and hit 8, just like we've been doing. Okay, so we have L1, L2. We want to go down here and put on our alpha trace, Y1. And just hit enter. And that gives us all of our regression information that we need. Now, I don't really care about this screen because if you notice, I've already given you that right there. Your A and B are right there. So we're not looking at that this time. We're going beyond that. Okay? So, at this point, everybody hit second Y. And we already did this yesterday. We're just going to tweak it a little bit. So, stat plot. We're going to hit enter, like we did previously. Make sure your plots are on. I had to turn mine off to make sure it's on. Now, notice we have L1 and L2, and we've chosen the first graph. That's what we want. So remember how we graph? We hit zoom 9. Now notice, we have 3 pieces of data below the line and 4 pieces of data above the line. So now, right now, you're just going to roughly sketch this. It doesn't have to be perfect. Just draw a line and kind of space out your data. 1, 2, 3, 1, 2, 3, 4. I mean, it doesn't have to be perfect. Just the general idea of the layout. And sketch that there. Now notice, this is our X, and that's our Y. Now we're going to go back and do it with the residual. So we're going to put a residual graph right here. We're going to put X here, and we're going to put the resid right there. So on the calculator, kind of makes sense. Hit second Y again. Go back in there like we were. But think about it. X stays the same. So we leave L1 for our X. But we don't want L2, that's our Y values. We want the residual. Now how do we access that? Everybody look here real quick. See the word list above stat? In blue? Hit second stat. And you should see residual at the bottom. If you see it like mine 7, you can just hit 7 or you can arrow down to it. Now all this is going to do is give me the residual plot. So right now we just hit zoom 9 again like we already did. And look what we have. We have that straight line. And what do we have? We have 3 dots below the line. And we have 4 dots above the line. The upper left-hand corner, you can see a little bit of a line. That's just the stored regression line from before. We just ignore that. We're just looking at the horizontal line and the above and below. So let's look at this data. Is there like a curvy, U-shaped, or exponential pattern in there? No, it's just random scatter. So we're going to go back to that statement we just learned. since the residual plot, and you can abbreviate resid if you want, shows random scatter a linear model is appropriate. And you can abbreviate appropriate if you want, or don't put too many P's in there. Very simple sentence. Since it's random scatter, we can use a line, basically, is what it's saying. We're just going to do it again, muscle memory. Practice makes perfect. So now, we're at our calculator. Notice I'm already giving you the regression information. Take our calculator. We're going back into stat, edit. Our x is staying the same. L1 is staying the same. We're just going to replace L2 with these new numbers. So 0.1, 0.8. Be very careful with your decimals. Make sure they're showing up. 2, 3.3, 5, 7.3, 9.9. Go over the residuals and clear it out, because we're going to want new residuals. Now we're just going to do the same thing we just did before. We're going to go to second Y, enter. We're going to go back down to Y and change this back to L2. How do we do that? Above the 2 in blue is L2. So we just hit the second blue button, 2. And then we hit zoom 9. It's the same procedure over and over. Right, something wrong with mine. That one messed up. All right. So, real quickly, go back to stat, calculate 8, and make sure you put in here alpha trace and pick Y1, because that'll move the line down. Now when we hit zoom 9,
You said stat copy.
yeah, like we've been doing. Put that alpha watt trace in there, Y1. That brings our line down. So, when we do a rough sketch of that, it's going to look like this. Draw your line. You have like one here, one there. Got like one on it, and one above. You got one on it down here too. So notice you have like 2 on it, a couple above, and a few below. All right. Now, if you look at it, you don't have to draw this, but you kind of see there's a slight curve to that material, just like in the first one we did. So let's see what the residuals look like now. So we're going to go back in here. Go back to second Y equals, enter. And all we're doing is going down and changing L2 to residual. How do we do that? Second list. For me, it's number 7. Once you have that, hit enter, zoom 9. Now, what do we have? We sketch that, draw a horizontal line. Notice we have a couple on the line here, one above, and then our other ones are like that. That's what you should have. So, do we have a curve or we don't have a curve? Well, right, so since the residual plot shows a curved pattern, again, kind of common sense, since it's a curve, a linear model is not appropriate. Moving on. There we go. So, if the linear model is appropriate, so if we do use a line, there are more values that can help us give more predictions. So, we love formulas. This is the formula for S, which is the standard deviation of the residuals. Okay? Don't worry. We're not going to calculate this. You're not going to calculate this. You'll be given S. Okay? We're not worrying in this class about how to calculate S, the standard deviation. You'll be given S. We just got to know, what does S mean. So, interpreting the standard deviation. And this is the statement we're going to use. It's a fill-in-the-blank statement. When using the, and again, we can abbreviate S, LS, RL, okay, when we're writing it ourselves. When using the S, LS, RL with X, and we just say what the X variable is, Y being the Y variable, will typically be off by S, whatever that number is. That'll make sense here in a second. We're just going to plug in the values from the graph. So S, what's the x-axis? What's the y-axis? Very simple. And then r squared, again, here is how to calculate r squared. We're not going to do that. We're just going to change r squared to a percent and write this statement. So it's going to be the same statement. You're just going to fill in the blank with r squared turned into a decimal, into a percent. Now we're going to use this statement. So about blank percent of the variability in y, whatever y is accounted for by the, again, you can say L, S, R, L, with x equaling whatever the x was. We're just going to fill in the blank from the opening paragraph. And then this is what our word tells us. All right, last page goes quick. Quicker than it looks. So notice, this is a residual graph. We don't even have the original scatter plot. We just have that. Okay? So we're looking at, notice we are given the line in the scatter plot. This is important for the filling in the blanks of those statements. X is price in dollars, Y is battery life in hours. All right? So, looking at the data, is a line appropriate? Well, there's no curve in it. There's no set pattern of a curve. All right? So, we use the same statement we did before. Since the residual plot shows random scatter, a linear model is appropriate. So since there's no curve pattern, basically, we can use a line. Now this part can be like write it in your homework. I'm giving you S. Don't care how to calculate it, I'm telling you what S is. So we just look back to the previous page, and we're going to fill in that statement. And here it goes. When using the least squared regression line with x equals, and then, like I said, this is right off the statement, it's a fill in the blank. So we look up here, what was x? Price. And we can put parentheses, a dollar sign. And y being, well, what was y? Tells us right up here, battery life in hours. Yeah, not residuals. We look at the original paragraph. Y is battery life. And we put parentheses, HRS, for hours. We copy the rest of this. We will typically be off by about, okay, what was the number they gave us? It's right here, 1.21 hours. And we always get this from the y value. So whatever the y value is, we put that in. So that S represents the y. And think about it, residuals are those vertical lines, okay? Y tells us up and down, so that's the way to remember that. And then lastly, we're given R squared. We know we need to change into a percent, so we move the decimal 2 places, so that's 34.2%. And then we just copy and fill in the blank the statement on the previous page. It goes like this. About 34.2% of the variability right, in battery life and you can put parentheses HRS, hours, is accounted for by the, again, instead of writing a whole big long statement out, LSRL, least square regression line, with X equal price, and put in parentheses a $sign. And that's it. Now, I do want to tell you something, make a note, because it does not show up in the book. For number 17, the book wants you to actually calculate S and R for parts C and D. That's just ridiculous. So make a note right here. For number 17, for part C, I'm telling you right now that S is 7.67. So you don't have to solve and calculate S. All you have to do is, just like here, part B, you just write this statement, except you're going to use 7.67 and you're going to use the words from that word problem. And then for part D, I'm telling you that R is 0.99. So just like we just did here, you're going to convert 0.99 to a percent, and you're going to write this statement using the information from the word problem. And that's it.